Hi everybody, my name is Pierre V2PS. I'm trying to build myself a magnetic loop antenna and I wanted to show you where I'm at right now and up to where I'll be working on the system. I'm pretty happy about what I'm doing right now and hope it'll all go well. It's experimentation and that's what I love about ham radio. You can experiment on a lot of stuff. And right now, this project managed to teach me a lot of stuff. So first of all, what's a magnetic loop antenna? For those that doesn't know, well, it can work on HF, VHF, UHF if you want, but usually it's a small, less than 1/10 of a wavelength antenna, and it's an high Q antenna, so you match it to the frequency you'll be using. So there are many good things. First of all, there's it's two lobe and two sharp nails on each side of the loop. So when you use it vertically, horizontally, it's both NVIS and DX antenna, since it's doing radiation like let's say a donut, big large donut. So it's sending a lot of signal toward up and at the same time on the side. So it's quite useful for both DX and NVIS. Okay, so I'm gonna explain to you a little bit what I've built. Right now, this thing is still in the building phase. It's not done. I didn't test much of it, but I'm building it, so I want to show you where I am. The first thing and the little thing before that I want to tell you how to I control that. You'll be maybe impressed, but you'll find that pretty cool. I'm pretty sure. So right now I have a 1-inch hard line. It's iliacs that I use as my first main loop. And I use a smaller loop made of copper foil to connect it to a one-to-one balloon. Why a one-to-one balloon? Well, it makes sense to use a balloon to pass from an unbalanced line to a balanced line, since the loop is a balanced line. So that's why I didn't want to have RF coming down from my coax, and that's a 5 kilowatt balloon. So since I wanted to buy one, well, if this thing doesn't work, I'll throw out the balloon and it will be useful. This thing is on old by PVC pipe. That's a white PVC pipe, and on this wood section, I have a variable capacitor. This variable capacitor from Comet is doing 100 picofarad to 1,000 picofarad. I know a lot of people will say it's a lot. I'm planning to put right behind the capacitor, knob, dog knob capacitor, which will be around 1,000 picofarad, which will bring the system down to 50 to 500 picofarad. But the capacitor, the capacitor is rated 100 to 1,000 picofarad. Right now, I can really use it from 56 picofarad to 1,024, or 1,028, 1,048 picofarad. So it's doing wider than the specification of the capacitor. I solder a strap, a copper strap, to the loop, and it's connected to the capacitor in this section here. And then I used two L brackets and soldered them to another copper strap, and it's screwed to the capacitor here. Right now, for those tests, I use a small wooden post, wooden post, some wood to hook my stepper motor to make a few tests if what's working or not. Then after that, I decided to put this thing aside and wait a bit more to work to prepare some stuff. So I want to show you where I'm back, and that will be, I'm pretty sure, something you'll like. So let's go here. That's a web page. This little web page is how I control the loop. Have a slider here that decide how many steps I can use, and my slider can be from 1 to 500 steps, or 1 to 5 steps, or 1 to 50 steps, whatever I want. The type of step I'll be doing is right now the controller I have, the step motor controller I have, can do full step, half step, quarter step, and 1/8 of a step. So I can decide which one, and if I want to go up in frequency or down in frequency. So if I want to turn left or right. So how this web page is working? Simply put, with a Raspberry Pi. Let me switch to the other camera.
So here's the other camera. Right now you can see the stepmother, and on my stepmother I've printed on my 3D printer a shaft. This shaft fit on the motor shaft, and on top of it there's a 5mm socket to put the 5mm Allen screw, and that screw is used to a lot of noise there.
And that socket plug into my capacitor. It's to replace the wooden part that I had. So as you can see, I have this little capacitor, this little step motor, and I've made it sure that you can see the one it's turning. So if I want to turn, let's say 27 full step on one side, I press on. Yep, not a good place. So I press on down, you see 27 steps. It's moving quite fast, full step. If I want to move it on the other side, there, and that's if I want to put 50 steps, there, it's turning quite fast. So if I want to make it turn fast, to tune up my antenna really fast, because I'm moving a lot of I'm switching bands, whatever. But I can move 1/8 of a step. So if I down, as you can see, didn't move much, but still it's the same 50 step that I choose, but it's 1/8 of a step. So if I really want to go to, let's say, 4 steps, for micro steps, which will be 1 step, there, it did 1 step. I don't know if you can see it on the, I'll do it a lot, but it's moving, you know. So I have high precision and fast coarse precision. It's all done on a little web page. That's PHP, of course, as you can see. But what's controlling it? That's the nice thing. It's my old Raspberry Pi connected to a Wi-Fi card, and that's connected to a breadboard. That breadboard connected to Easy Driver. Easy Driver drives my motor with those 4 wires there, and I have a few lines that control that goes to the Raspberry Pi, and the Raspberry Pi with it's driven by all software, and that software drives the motor, how many steps, which direction, if it's a full step, quarter step, whatever you decide from the web page. I didn't code that. It's one of my friends, another ham. He doesn't want me to name him, so name it. So he doesn't have too much requests coming for him to do that kind of stuff. But he did gave me permission to share it with others. So if you need the source code, whatever, no problem with that. I can share it with you. So That's the project up to where it is, but that's not the end of it. First of all, if I can see that my capacitor need more precision, I'm gonna switch the driver to this little thing. This little thing is a DRV 8825, which can do same exactly as the driver with more power, and it can go up to 132 of a step and 116 and 132 of a step. So can do much more precision than the easy driver, but can still do full step, quarter step, half step, name it. So this little thing is quite useful. I'm not sure I'll be using it. It all depends. Since the capacitor can do more than 11 turn to switch from 56 puff to 1048 puff. So that's pretty in the puff or picofarad. So um, so that's the project right now. And there's another thing I want to put on the website, on the web page, not website, a little graphic that will tell me the field strength of the antenna. And for that, I'll be using the ADS, ADS 1115. That's from Adafruit. And this little thing is connecting with the computer with I2C, and it's an analog to digital converter. So there's 4 inputs on this little device. I'll be using one, and I'll be using a small diode, and then the small antenna and capacitor, like any field string. I'll feed the signal to this little thing that will be able to give me up to where the signal is, and of course, the more coupling with the more power will be sent by the antenna to mean that the antenna is well tuned to the frequency I'm using on my transmitter. So I'll be using that to tune my antenna. And the next step on the programming side is being able to display this field string and to use it to auto-tune the antenna. So the software will be able to read the information, sending back the information to the C software. The C software will say, okay, let's turn left a bit. Okay, the field string is going down, so let's turn right on the other side up to a point where I'm passing by too much, and then coming back and auto-tune. The capacitor will auto-tune to the frequency I'll be using. So that's something that I need to do. One other thing I need to do is to put in some limit switch to the shaft. So on the shaft itself, that's something that I printed quite fast now just to make a proof of concept and test a few things. And I want to put some teeth here to and a small another wheel with teeth to engage to and make some a way of knowing if it's up to one limit or the other. So with some limit switch. So that's a few other things for the project, but that's where I am right now. So I wanted to show it to you. I hope it's giving you some idea. No, it could be giving other people some other idea. If you want the source code and the PHP page, it's basic. It's there's not much command on it. It's just there to play with it. So it's kind of simple and dirty. So I'm not a good coder. My friend is a good coder, but I'm playing with this. So and like I saying, there's another ham don't want to be named, but just one thing, Patrick, thank you very much. You're the top on on the coding side, but that's a lot better than me. So I hope you had fun watching it, and I say have a good day.